Have you ever thought how your computer watches cat videos using nothing but zeros and ones? It's like communicating with someone using only hats and nods and eyebrow wiggles. Did you come across the meme? There are 10 kinds of people in this world, those who understand binary and those who don't. In this video, I will help you to understand the binary numbers so you don't have to bang your head on the wall all the time you come across the binary term. In this video, I will cover the binary topic in a gaming way to make it fun and exciting. Make sure to stay until the end when we will do multiple binary math practices to solidify our understanding at the next level. Are going to practice 5 exercises together, and if we successfully complete all of the exercise, our maximum score will be 100. Imagine if we still use the tally marks for counting. Every time someone asked your age, you would have to whip out a notebook filled with endless pages of vertical lines. Birthday cakes would collapse under the weight of all those candles. Thankfully, the base 10 system came along and said, let's bundle this ugly tallies into neat groups of 10. So instead of making your grocery list with symbols, you can jot down the numbers that don't look like a failed attempt at modern art. Base 10 didn't just simplify math, it saved entire forests from becoming tally sticks. Think of the base 10 number system as a numerical soap opera where digits line up from left to right, each with a dynamic increase in importance. But every step to the left is like climbing a 10-story building. The tens place, hundreds place, thousands place, and so on. Each digit to the left is 10 times more significant than its neighbors. So, reading numbers from left to right is like watching dogs gain superpowers. Thanks to base 10, we avoid scribbling endless tallies and keep our counting numbers from going on strike. Think of binary and decimal as two different chefs following the same recipe but with different ingredients. In base 10, we use 10 digits, which is 0 to 9, because humans conveniently have 10 fingers. You could count it from the on your right hand, like 1, 2, 3, and if you count it, then you get 10 numbers, right? Which is the nature's built-in abacus. Each digit's position from right to left represents increasing powers of 10. So moving left is like adding zeros to your bank account. Each spot makes a big difference. On the other hand, binary is like the minimalist chef who insists on using only two ingredients, 0 and 1. Despite the limited menu, the cooking method is the same. Each digit's position represents increasing powers of 2, doubling the value each time you move left. Kind of like stacking scoops on an ice cream cone. Each scoop makes it twice as delightful. So, binary is just decimal's simpler cousin, who decided that less is more. Asking a computer to juggle 10 digits is like asking a dog to do your taxes. So now we know that computers only use 0 and 1 to process their data. If they were to use the decimal numbers, it might have taken a long time to process those data, and your computer would have crashed by getting overwhelmed because of the numbers. Meanwhile, 0 and 1 can be used very quickly. Zeros and ones can be compared as the switch on and off, true and false, yes and no, and whatever you may like to imagine. So in binary, we only use two digits, 0 and 1. Each digit is called a bit. 8 bits together will be 1 byte. 100 bytes to 1 kilobyte, and the cycle continues. Now you can imagine a faucet controlling water flow. When the faucet is on and water flows, it represents a binary 1. When it's off and no water flows, it represents a binary 0. Transistors in a CPU work like these faucets, controlling the flow of electricity, similar to the water flow to represent binary digits. These transistors process binary numbers by turning on and off rapidly, enabling the CPU to perform calculations and execute instructions. This simple on and off mechanism allows computers to handle complex tasks using binary code. We have already covered the binary basics and now we have leveled up. And now we are going to the next level. Imagine that zero is a king who always returns you with 1. It's like he is equal, so he does not return you with 0. So if you have anything 0 on its head, it's going to return you 1, not 0. He is very equal with everyone. So if you have a king on your head, for example, if you have a king on two's head, it's going to give you 1. It goes the same for every one of the numbers. You have 0 on your head, don't worry, you are going to get 1. Similar to what we had used in our 10 and decimal numbers, if we go from the right to left, the position increases and it keeps on going from 0, 1. And similar to this, we have in the binary section, we do the same thing. The more we go from right to left, the position keeps on increasing and then power of 2 also keeps on increasing. So the more you go right to left, the number keeps on increasing and they will be used as the head on the head of the 2, and it's like the crown that you had been trying to wear. So if it is 2 to the power 0, it's 1. If it is 2 to the power 1, it's 2, it's obvious. And 2 to the power 2 is 4. And what if it is 2 to the power 3? Duh, it's obvious it will be 8. So it's like the 2 is gaining superpowers until we get to the power 2 to the power n. It will keep on increasing and increasing. You may like to use the calculator. So our main would be 2 to the power n. The positional value and 2 together are going on strike together and they are going to say, yes, we are going to win the war against the binary numbers. So they want to get more power. So the positional numbers and 2 have already been allies and they want to multiply with the binary digits, which are 1010 or whatever it is. They multiply together and they give us the value. So they are multiplying the binary digit with the 2 to the power n. If the binary digit is 1, then they are going to give us some values, which is great. However, if the 2 to the power n combines or multiplies with the 0, you know what happens when you combine 0 with something, or just say you multiply something with 0. Duh, you're going to get 0. Or maybe you could say like it's a coffee break. To make the process more smoother, to convert the binary numbers into our normal decimal numbers, we will be using a binary table where we are going to use position and value, and we will be going exactly similar like the decimal numbers from right to the left. The more we go from right to left, the powers will keep on increasing. Oopsie, I wrote 2 to the power 3. It should be 2 to the power 2, which is 4. Then we will keep on increasing the numbers based on the powers of 2. Now we have known the basics, we are going to start practicing so that we know that we have solidified our understanding. And we are going to start with the 1 0, which we have already known binary meme, right? So here we will be using two methods. One would be the normal one we can use, or we can use the shortcut method, which is the method 2, and it will be based on the binary table. So for our 1 and 0, we are going to multiply that 2 to the power positional value with the binary digit. If you multiply 0 with 2 to the power 0, you're obviously going to get 0. However, if you multiply 1 with 2 to the power 1, you are going to get 2. So if you sum up the numbers you got, which is 0 plus 2, you are going to get 2. And this is the result. And we are done. Now we are going to move forwards to the second method. And if you use 0 and 1 to the digits position, and you cross the value with the digit numbers, and 0 is in the coffee break, so we cannot use the 0 because it will not help us in any way. However, 1 has a good number value, so the value of 1 is for this term is 2, so we are going to pull out the 2. Congratulations! You just converted a binary number to a decimal number, which is 10. So now you have known that 10 does not refer as the 10 in decimal. It only refers to 2. In the binary meme, it meant that one who knew binary and then the one who didn't knew binary. So it only refers to 2 people. Now we are moving towards the second example, which is 101. Now we are going to do the same thing as we did for the example 1. We are going to write 101, and then we are going to multiply the binary digit with the 2 to the power positional value. And if we get 1, and if we multiply the number with the binary digit 1, we are going to receive the values. Or if it is 0, then boom, no, we don't need you, just go away from here. So when you combine the numbers together, you get 1 plus 0 plus 4 equal to 5. Boom, you got the answer, which is 5. Now we are going to use our second method, which is directly inserting the digits on the digit box we have created. So we will write down the digits, which is 101 from left to right, and we will see which value does the position holds, and we will try to pull out the numbers, and we will go as is usual from left to right, and we will try the first one. We will pull out the number, which is 4, and plus we will pull out again also, and we are going to pull out the number again 1. So if you combine the 4 plus 1, which is 5, and the result is 5, we got here with the answer. Now we are moving forward to our third example, which is 1110. And if we complete this exercise, we are going to get 80 XP. Now we are going to do the same thing as we did for the example 1 and example 2. We are going to use two methods. One is the normal one, and the second one we will use the shortcut method, which also takes the help of the binary table. And so for the first method, we are going to multiply the binary digit with the 2 to the power its positional value, and if 0 is used, it's same going to the coffee break, and if it's multiplied with 1, then yuppie, we are going to use that number, and together we will sum up the numbers together, which is 0 plus 2 plus 4 plus 8, and it will be equal to 14, which is the result of our number. Now we are going to use the second method, where we will use the digits and from left to right, and we will use the digits in the digit box and we will go from the left to right, which is 0 1 1 1. Now we are going to pull out the numbers that has value of 1. Pull out for 8 plus 4, pull out, and we got 2. So if you combine them, all of the numbers together, we get here 14, which is the result. Now we are going to convert the binary to decimal number 10010 and see what happens. But before we dive into the answer, I want you to try it yourself. And if you can do it by yourself, then congratulations. It means that you are trying to understand and you are actually going beyond your comfort zone. As we did with the earlier ones, we are going to use the two methods. One is the normal one and the second is the shortcut method. So the first one, we are going to multiply the binary digits with its two positional value, and if it's multiplied with 0, then forget it, just forget it. If it's 1, then congratulations, just multiply it with a 2 to the power's positional value and you're going to get the number. After you complete your multiplying with the binary digits, you are going to get 0 plus 2 plus 0 plus 0 plus 16, which is 18. And it's your result. Congratulations, you got your result. Now we are moving toward the second short method, which is we are going to go from the left to the right of the binary numbers. And for that, we are going to write the binary digits in the digit box, which is 0 1 0 0 1. We are going from left to right, and again we are going to pull out the numbers as we did earlier, and if it's 0, don't count it, just count for the ones, and when you count it together, then you are going to get 16 plus 2, which is 18. If you're able to solve this by yourself, then congratulations, you are one step ahead and you are trying to understand what the binary is. We are almost done with our binary to decimal and we are at the last example, and if we get this, we are going to get the 100 XP. Our 5 number example is 101101, and let's see if we can do it right. As we did with the earlier ones, we are going to use the same method which we did for the past 4 examples. We are just going to multiply the binary digits with its 2 to the power positional value, and if it is multiplied with 0, then don't count it, just move forward. Only multiply with 1 because that's the legit one we are going to need. To complete your multiplying, you are going to get 1 plus 0 plus 2 plus 8 plus 0 plus 32, which refers to 43. Boom, that's your answer. You get the answer. Now for the binary number, we are going from left to right and we are going to insert the numbers on the digit box and see if any value has 0. No, we are not going to use it. We don't need use 0. We are just going to use 1. And 1 is going to give us some values. And if you combine all of the numbers together which has 1 digit, so congratulations, you're going to get the number, which is 43. Yo, congratulations, you just got at the end of the video and you just literally got 100 XP. And that's the end. You just literally overcame your fear and now you are going to move forward. If you found this video helpful, please subscribe to my channel for more tech tutorials and leave a comment if you have any questions, and I will see you next time.